Short response.
Right? If y'all could look at the free response question, the long one, and let's see if we can name the types of intermolecular forces that you're seeing. So the structures of the two compounds, lauric acid and sucrose, are shown. Which compound is more soluble in water? Justify your answer in terms of the IMFs present between water and each of the compounds. So which one do you think is more soluble in water? Sucrose. And why do you think that's true? Well, sure. But in terms of the intramolecular forces,
There's less electrons, but it's got less.
okay, so you could talk about in terms of more electrons, less electrons kind of a thing. You could also, but I bet you if you added up, they're close there. Y'all remember what it takes to make a hydrogen bond? I'm gonna guess no, just based by the giggles. So, what does it take to make a hydrogen bond? Just for your intermolecular forces? You gotta have a hydrogen on one molecule connected to something pretty electronegative, either fluorine, oxygen, or nitrogen. Has to be one of those three. And then on another molecule, you have to have something pretty electronegative. So you have to have a hydrogen hooked to one of these three, and then on the other molecule, you have to have one of these three. And this is going to be a negative end, and that's going to be a positive end, and that bond between them is called a hydrogen bond. Can that hydrogen make a hydrogen bond? What do you think? Why not? It's a hydrogen. It's bonded to a carbon. It's not bonded to a fluorine, oxygen, or nitrogen. Do you see in this entire molecule a hydrogen that can hydrogen bond? What about this guy on the end?
Yes.
So how many places can that guy hydrogen bond? One. Do you see on this molecule any hydrogens that are capable of hydrogen bonding?
Yes. Lots.
That one,
The one with the what?
that one, that one, that one, that one, that one, that one, this one right here. So sucrose is going to have more hydrogen bonds because it has more places to bond. This is why sucrose is dissolved in water, because it can form so many more of those hydrogen bonds. So, what type of bonds does lauric acid show? Because it wants to know the intermolecular forces present between water and each one of them. What kind can it form? It can form hydrogen bonds, and what else? Does it have London dispersion forces?
Yes.
Who has London dispersion forces? Everybody! It's okay. I got you. You too. Everybody. What does it take to have a London dispersion force?
Having electrons.
Electron. What kind of bonds does sucrose show? Hydrogen bonds. Anything else?
London dispersion forces.
London dispersion forces.
So there is.
But this one can do a whole lot more with water than this one can. Right? Now, let's say you couldn't do part A at all. You're like, I don't even know. I'm going to give up on question number 3. What kind of question is letter B?
It's a give me question.
It's a,
Specific here, what?
okay, gives you specific heat of water. Calculate the final temperature. This is not a question that has anything to do with find the intermolecular forces. It's more of a Q is equal to MC delta T, or a energy, it's a thermo question.
This is a given question.
And just because you don't know A does not mean you don't know B. In other words, when you see a question on the AP exam, you want to answer all the parts of it. Reasonable? Y'all should have not known a lot of this. Is that what you feel like?
Yes.
Good job. Okay. I got that we're
Yeah,
fine.
yeah.
So you guys are moving across the hallway. Don't forget to take all your stuff with you.